Hi everybody! So in today's video we're going to be thinking about finding a volume. Now up until now we've strictly been finding the areas of shapes using integrals. Today we're changing gears. We're going three-dimensional and we're going to be finding volumes. When we find a volume, there are a few formulas you're going to need to know. What I'm going to do right now is show you how you can derive or figure out these formulas on your own so that you don't necessarily have to memorize them. However, if you're more comfortable with saying, okay, I understand where they come from, but I'm just going to, try to remember them without having to figure them out individually every time, that is also okay. So let's start with, what if we have a square and we know each of the sides is s? Then the area of the square would just be s squared. Pretty straightforward. What if, however, we have a square and we know that the diagonal is d? So now we don't know the size of the sides, we only know the size of the diagonal. Well, because this triangle is going to be a 45, 45, 90 triangle, each of the sides would be the diagonal divided by the square root of 2. So the area of this square now would be the diagonal divided by the square root of 2 squared, which would be d squared over 2, or in other words, I usually write it as 1/2 diagonal squared. Now at the end of the day, I need you to know this formula, that the area of a square with a given diagonal is 1/2 diagonal squared. But if you want to derive it and figure it out every time, that's totally fine. What if we know we have a semicircle whose diameter is d? Well, in order to find the area of a circle, we need the radius. So the radius here would be half of the diameter. The area of a semicircle would be 1/2 pi r squared. And we just said that our r would be 1/2 of the diameter. Now 1/2 squared is 1/4. Times 1/2 again would be 1/8 pi times the diameter squared, which would be pi over 8 diameter squared. That's what we usually write for our area formula. What if I give you an equilateral triangle whose sides are all length s? To find the area of a triangle, I need to know the base, which is s, but I also need to know the height. In an equilateral triangle, we have a 30, 60, 90 triangle. So this height would be the square root of 3 over 2 times s. So the area would be 1/2 times the base, which is s, times the height, which is the square root of 3 over 2 times s. Which means if I simplify this, we usually write it as square root of 3 over 4 s squared. What if we have an isosceles right triangle, which means these two are the same, this is a right angle and these are 45 degrees, where the legs are length s? Well, then the area of that triangle would be 1/2 times the base times the height, which is 1/2 s squared, or essentially what it really is half of a square. Now on the other hand, what if we have a right triangle where we know the size of the hypotenuse? Then each of these legs would be the hypotenuse divided by the square root of 2. So your area formula would be 1/2 times the base times the height, which ends up being 1/4 h squared, or essentially half of one of these because we have the same diagonal information. Now, at the end of the day, you just need to be able to come up with these formulas, so don't feel the need to memorize them necessarily every time, but just to be able to figure them out when you need them. As we saw in class, what we're going to be doing today is starting with a flat surface, and we're going to be building cross sections. The cross sections are going to stand up out of the paper. It's three-dimensional. And those cross sections could be constructed in such a way that each of the cross sections is perpendicular to the x-axis, or each of the cross sections is perpendicular to the y-axis. Now, depending on what you're given in the problem and what it describes to you, this changes how you would set up the integral. So if your cross sections are perpendicular to the x-axis, that is your clue that everything should be done dx with respect to x. If your cross sections are perpendicular to the y-axis, that is your clue that everything should be done dy, or with respect to y. So how would you set this up? Well, if your cross sections are perpendicular to the x-axis, then you're going to integrate from a to b, or in other words, from the smaller x value to the higher x value. Inside the integral, because we're going to add up all of these cross sections, you're going to put your area formula in terms of x. And finally, you would put a dx at the end. If your cross sections are perpendicular to the y-axis, then we would integrate from, we call it c to d, because this is the y value to the y value. Inside this formula, you would put your area formula for each of your cross sections with respect to y. dy. So let's take a look at how this would work. For problem number 1 here, I've already provided you with the graph, and it says in the directions, the region bounded by the graph of y equals 2x minus x squared, so this picture, and the x-axis, so we're supposed to use this as one of our boundaries, is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an equilateral triangle. As we saw in class, from above, when you're looking at the base, our cross sections just look like straight lines because they're so skinny. And since they're perpendicular to the x-axis, we draw those straight lines going vertically. In other words, perpendicular to the x-axis. What is the volume of this solid? Now for this one, we're going to use a calculator. Here's how I want you to think through these problems. In order to find the volume, we're going to add up a bunch of areas. So let's start with the areas. The area here is the area of an equilateral triangle. Now our area formula on our previous page that we derived said that the area of an equilateral triangle is the square root of 3 over 4 times your side squared. In this problem, the sides of the equilateral triangles run from top to bottom, because each one of these little lines is a side of a triangle. So the next step would be, if this is the formula, how do we get the formula in terms of x? We need an x here instead of an s. In this problem, s could be calculated by going top minus bottom, the distance between these 2 points. So the top here is 2x minus x squared minus the bottom here is 0, which simplifies to just 2x minus x squared. And again, we got this by doing top minus bottom. Now let's pull it all together. Our volume, so you'll notice I wrote volume here, V for volume, would be the integral between the beginning x value, which is -1, and the ending x value, which is 3, of our area formula. Now our area formula is the square root of 3 over 4 times s squared. And we said that s was 2x minus x squared, dx. So all I'm doing is substituting this into here to create this formula. Now, I'm just going to type it in on my calculator. Math 9, -1 to 3, square root of 3 over 4 times 2x minus x squared dx. And I got 2.656 be the volume. Okay, now let's look at another example. This one says the base of a solid is the region enclosed by y equals e to the x and y equals 4 and the x-axis, or sorry, the y-axis. So the y-axis is one of my boundaries, this curve and this line. It looks like we're looking at this little section right here. Cross sections perpendicular to the y-axis. So we're going in this direction, and I'm going to draw them in that direction so I can visualize this, are rectangles whose height is twice the length of the base. Find the volume of the solid. So the first step is, which direction are my cross sections going in? Second step is, what area formula do I need? In the previous problem, they just said they're equilateral triangles, which was an area formula that we learned that we could use. In this problem, they say our areas are all rectangles, whose heights are twice the length of the base. So our area formula is not a formula that we already wrote down on the other page. We're going to need to figure it out. The area of a rectangle is normally base times height. But it tells me in this problem the height is twice the length of the base. So if I plug that in, my area formula would be b times 2b, which is 2b squared. Step number 2 is, well, how do I put b and make it in terms of y this time? So normally when we think in terms of y, we think right minus left. The right side here is y equals e to the x. But since I'm going from right to left, I need to change this so that it has a y in the formula instead of an x. So in order to do that, I'm going to rewrite this as x equals the natural log of y. So I would have the right side, which is the natural log of y, minus the left side, which is 0. So I would just have the natural log of y. Finally, I would set up my volume. My volume is going to go from this lower y value, which is 1, to the higher y value, which is 4. Then inside here, I'm going to put my area formula, which is 2 times b squared. So I'm leaving a space there. Instead of b, I'm going to fill in what I figured out in terms of y. And then dy. Finally, I'm just going to type this in on my calculator. So I'm going to go to Math 9, integral from 1 to 4 of 2 parentheses, natural log, now remember, even though it says y, we're going to use x, squared dx, and we get 5.194. Okay, so I hope that this makes sense, that you can set this up in terms of x or in terms of y, depending on the direction of your cross sections. You might use an area formula that we have on our list on the other page, or you might use an area formula that you have to create based on the given instructions. And finally, after you set it up, make sure that if you're doing everything in terms of y, everything here needs to be in terms of y. If you're doing everything in terms of x, everything here needs to be in terms of x. Can't mix and match. Lastly, just type it into your calculator and you're good to go. So we are going to go ahead and stop here for now. We will do problem 3 in class tomorrow before you get started on your practice. All right, see you then.